Hello students, in this video let us see the second unit of software engineering, that is about the software requirement specification and some of the analysis included in it. So what is this requirement? You all know when we develop a software we need to know for what we are developing. Like it should have a plan, like what is the need of developing that software. So that is an important aspect even before you start developing a project, right? So you should know what you're developing or what are the customer needs. Only when you know this and you are thorough with what is needed by the customer or the client, then what you do, you come up with the actual code and the design how it should be created according to the wish of the client or the customer. So, the most important task or the difficult task, or you can say the basic task in the project itself, is identifying the requirements. So, what are requirements? It's like nothing but what the client actually requires, what the client intends to get from you, or what he wants you to create for him, because he pays the money for you for whatever you are developing, and he has to be satisfied with the product whatever you have developed. So identifying requirements is one of the important and the basic thing, and for this itself a lot of time goes when you are actually developing a software, and this is one of the main stages of a software development. So for small scale it is easy to understand and specify requirements, and understanding the client perspective is also easy. But when the project is large, it becomes difficult. And if the project is still large, it becomes difficult to understand what actually the client wants. Like in every small function, whatever you are using, what is the client is hoping to have or hoping to work on when you finish your project and give it in his hand. Okay, so that is the problem actually arises when the project is a large one. So here the input you can say as a user needs in minds of some people, like who are the clients are, whatever they are input is, whatever they are needs is there that you have to actually fulfill. Okay, and it is actually in their minds. Okay, they don't write and give it to you, so these are the needs. So they will tell you how a software should be, and you need to do the list of things that they actually need. Next is the requirements phase, that is it translates client ideas from their minds into formal document. This is what actually we do. Other software engineers at the starting, when the client says the requirements, he has to take the he has to make a formal document of it, like whatever it is required. Next is the output. In the output, what do they do? They make the statement what the future system will do according to the client, whatever he has said, the ideas whatever he has said, according to that what will be the output in the system we can see. Okay, that is put. So it becomes like origin of software system, that is the need of clients, then creation of software system, that is by the developers, and completed system used by the end users. So identifying and specifying requirements easily, it actually necessarily requires people interaction in the sense client and the one who develops the software, and usually it is a member from one of the teams in a company. Okay, and it cannot be automated. You cannot simply tell it like uh, just tick some of the things and make a checklist and give them. It does not happen like that. He has to say it in sentences in using natural language, and they have to convert it into the design or the especially first thing they have to convert into a software requirement document. So, requirement is defined by IEEE as a condition or capability that must be processed by a system, condition, or a capability that must be met. So, requirements phase ends with the software requirement specification, that is SRS document. So, the definition says that it is a condition or capability that must be possessed by a system. System in the sense here it could be a company, a team, whatever it is, or a condition or a capability that must be met. Whatever the client is saying, the company has to do it and give. Okay, so that is nothing but the requirements definition. So then what is the goal of this SRS? SRS specifies what the proposed system should do without describing how the software will do it. Its intention is only to say what it has to do. How, that will be discussed in the next coding session and design session, all that. But in the SRS, it should always say what it is supposed to do. So understanding the requirements is hard. Like, see, some system does not exist as such in the a society or even the market. It does not exist, but somebody comes up with the idea. So visualizing that future system is sometimes becomes difficult because you have not seen that, or you have not even heard of it of any kind. So that becomes difficult. Then capability of the future system may not be clear. The technology goes on changing every now and then, and you do not know in future years what the technology would do. So in keeping in the mind the technology that is going to be developed, and based on that you are trying to develop a system, it becomes very very difficult. And requirements change with the time. For example, when the situations change, when the surroundings change, you actually tend to change your requirements also, right? So there are so many impediments for these requirements handling. So what has to be done? Essential to do a proper analysis and specification of requirements. When you develop a software, this thing is very important that you do a proper analysis and specification of requirements. Why? We'll see the need for this SRS. See, SRS establishes basics of agreement between the user and the supplier. Okay? The need for SRS. Why this SRS is needed? Because it's a kind of agreement between the user and the supplier. User in the sense who actually wants it, like clients. Supplier is the one who provides the software. Okay? So user needs to be satisfied, but he may not understand the software, what actually is going on in the software he doesn't know, but and he's not even worried about it. What he wants just the output. And developers will develop the system but may not know about the problem domain. Like what they do, developers, you might have known if you are friends or brothers or cousins who are working in the software system, they will not be knowing the whole project what it is about. They will be given a small module or a small part of it, and they have to develop it, and they will be told what they have to develop, that's all. So they do not know what actually the problem is, what the client has asked for. Somebody will chop it out and do whatever come up with the ideas whatever has to be done according to the client requirement. Later it is shared with the developers, and developers, what they do, they are not worried about what the problem is. They are worried only about what their manager or the team head says. See, you have to do this, and they do that. So they are not worried about what the problem domain actually is. And SRS is the medium to bridge the common gap and specify user needs in a manner both can understand. Why is this SRS? One more thing is, see, a normal client or who is not aware of the software terms and all that, he explains everything in his own natural language. Natural language, we mean to say English or the Kannada, Hindi, whatever the language the people speak. Okay, we have one more type of languages, right? The computer languages, C, C++, C sharp, and all that. So these are the computer languages, and natural language is the language that we use to speak. Okay, so the common man comes up with the natural language and he says what he wants. You cannot use a natural language to have the programs, right? You need to convert it into what? Computer language. So it acts as an a bridge between these common man or the client who wants the software and the one who develops the software. So this is again an important question students need for SRS. You need to know. There are four mainly, and you need to explain this also. So SRS helps user understand his needs. The SRS, when it is documented and shown it to the user, he comes to know, okay, what actually he wants. See, he may have a rough idea in his mind, and he may come up with like, I want a software for this problem. But this it's not just the software. When somebody says I want a software for one problem, you are not actually developing just a software for one problem. There are few associated problems with it or associated information related to it, and you need to display or give the same facility for the client, so it helps him to understand better. And user do not always know their needs initially, and when they come up with the problem, they just come up with the main problem. There might be some associated problems with this, and which they will not be aware of. So that also it helps to understand it. Then he must analyze and understand the needs, like what actually is needed to do and what has to be done. Then this requirement process actually helps to this clarify these needs. Next is SRS provides a reference for validation for the final product. What do you mean by that? See, at the end of the software development and when the project is ready, you need to see if the project meets whatever the client has asked for. See, otherwise the developer simply may develop some other software and give it to the clients, right? See, that does not happen. I mean, that is not feasible one. That cannot be said as a good software, because the request of the client was something else and the developer has developed something else. That cannot happen. Then how will you say whether the client whatever he has said is done by the developer? You cannot say as it is. So we need this SRS that states a clear understanding about what is expected, like what needs to be done. So when that what needs to be done is met in the project, we say we can validate that whatever the requirements was given by the clients has been satisfied. Okay, so that is what the second statement means. The third is high quality SRS essential for high quality software. That is, SRS actually defines what the software has to be about. If the developer develops according to the each specification of the client, no doubt the software will outstand and the client will be very happy to use, because he will have every information, every option in the software that he was expecting, right? So high quality SRS is actually required for the high quality software. So what happens if this is the case? Requirements defects are not few usually, because they come with the errors. Like, well, it's just a word of mouth, right? Clients come and say in their language and you just have to grasp what it is. So there could be mistakes, and to satisfy the quality objective must begin with a high quality SRS without errors. If you make the SRS without errors and if it is perfect, obviously your project will also be a successful one. It will be a great success, because everything the client has asked for is in the software. The client will be really happy and appreciate your work. One more thing is a good SRS reduces development cost. That is, what they mean by this is, see, once the SRS is given and you start developing the software, in between there are no add-ons. Okay, like once they have given and finished, and you just give the end product. If your end product is very good, no problem, the client will be satisfied, you give them and they will be happy. But in case there are some errors in SRS, or the client wants something else when you are preparing, or he got some other ideas and he is asking you to inculcate that ideas in your software, then what to do? If and by mistake there arises some problems in the software, then what you do? See, once you have started the software or you have already developed it, then you cannot ask for a change. If you ask for a change, then what happens? It costs. That is the thing. It's not that you cannot change, but it adds up to the cost. And you cannot ask for that extra cost with the client because he never said, like, I'm not going to ask for the improved versions or new ideas. He wants that in the software and he is not ready to pay extra for you. So what will you do? With the same budget you need to put these extra things, and whatever, if at all it was a mistake, there were some mistakes in this, the earlier whatever you have paid for the developers, it cannot be taken back, right? You have to, it is like a double work and you are simply paying for the manpower, and it's a loss for you. Like if you are the company owner and he is trying to have some profit with the project development, then it doesn't happen. So good SRS reduces the development cost. When if development cost is less, then the company will make a profit, right? So here is an example how this happen. That is, for example, if you take some of the phases like design, coding, acceptance testings, operations are like percentage wise 2, 5, 15, 50 and 150% months. Okay, that like 2% are needed, 5% are needed, 15 people are needed, then 50 people are needed for to fix the errors like design errors, coding errors and acceptance errors. Then see, after requirement phase, once it is done, then 65% requires errors detected in the design, 2% in coding, and 30% in accepting, and 3% in during the operation. To overcome this, you will have a man hours required. That is, you are giving what? For hours you are paying, right? You are paying the salary, or in terms of package it may be, or outsourcing, whatever it is, but you are paying that people. So if you have lost this 1152 hours, then what you are going to have as a profit? It's a great loss for the company, right? So that is why this is an example how it happens. You can go through this again very deeply, you can understand what it is. Then requirements process. Then how this is done? If we have told so many things why requirements SRS is required, then how do we do this? As I told you, it's a formal documentation. How do we do? Sequence of steps that need to be performed to convert user needs into SRS. That is, process has to elicit needs and requirements and clearly specify it. So the basic activities include problem or requirement analysis. First you have to analyze, then you have to specify what is the requirement, then validate the requirement, whether the stated requirement is validated, that is it feasible to do with the current technology that we are having. And analysis involves elicitation and the hardest, and is the hardest. So it's a little hard to analyze and come into the conclusion like what is needed, but it's the process. So this is the requirement process, that is the user or client needs, he says, that is analyzed, that is specified. If the specification is satisfied, then it goes for the validation. If it is not satisfied, again it goes for the analysis, and in again comes back to specification and validation, and in validation it does not satisfy, again it goes to specification, and even if when specification it is not satisfied, it goes to analysis. So this continues until you get the validated SRS. So this process is not linear, that is, you can say it's iterative, right? We have seen like a loop. Every process goes to it has a choice to go back again and again check and come back, right? So it is iterative and it's a parallel, simultaneously things can go on. Overlap and feedback between these activities keep on happening, and specification itself may help analysis, and validation activity reveals problems in the SRS, leads to further analysis and specification. validation helps in this analysis and specification. For complex systems, when there are so big projects, divide and conquer strategy is used. You know what a divide and conquer strategy is? See, there is a whole problem. You divide that problem into smaller problems and you solve individual problems. Okay, so that is divide and conquer strategy. In the requirement process, we have several sub points like problem analysis. As I told you, when we have a problem, first thing we have to do is we should analyze the problem. So it starts with a high level problem statement. There should be a statement for this, and for that statement there should be a model like problem domain and environment where it is to be solved. Then the focus, that is understanding the design system's behavior, constraints, inputs and outputs. So for this we use the techniques like DFD, object diagrams, etc. And DFD will be seeing in the coming slides. Methods of analysis and design activities are same, but analysis deals with the problem domain, that is understanding the system, and design deals with the solution part. Okay, so you understand the difference, right? Analysis is you are trying to figure out what actually the problem is. Design is like you are trying to solve the problem. So focus is like clearly specifying the requirements, what is actually required. Next is analysis. Structure helps in specification, but transition is not final. It helps in structuring the specification, but that cannot be final. And transition from analysis to specification is hard. It's not that easy. And external behavior also should be specified. So for this, the input is large amount of information generated via analysis, and the goal is to properly organize them, remove redundancies in the sense same thing repeating again and again, and describing requirements, what actually the requirements are. And issues like representation, specification, language and tools are all addressed in this. So next, the main thing is a SRS characteristic. This is also again important question, students. You will be getting this for the exams. It should be correct, complete, unambiguous, verifiable, consistent, ranked for importance or stability, modifiable, traceable. We'll see these things one by one. What do you mean by correctness? You understand. It has to be correct, right? It should correctly or accurately represent what is required. So it is a desired feature in the final system. Next is completeness. You understand what completeness is? You cannot have a half SRS, okay? Whatever the SRS is there, it should be full. The half SRS does not work here, okay? So that is the completeness. Unambiguous in the sense, there should not be a dilemma, like whatever the specification or whatever the problem is, the solution for that should be one single answer. Okay, so there is one, like it's like one question, one answer. There cannot be two answers. Okay, so that is unambiguous. And verifiability, so there must exist a cost effective way of checking if the requirements are satisfied or not. Especially it is usually testing, or you ask the clients to work on the software and ask for their feedback and verify whatever was needed is done or not. Consistency is two requirements do not contradict each other. That is, you in one space or at the starting of the project or the SRS, you put one as a requirement, and the second stage or in the in the next further projects, what you do, you again put some other requirement related to the first one. That should not happen. And ranked for importance and stability, that is needed for a prioritizing in the construction to reduce risk due to changing requirements. That is, what is the first, like what should be developed first, which is important, that is developed and kept, and the smaller things are kept for the end so that easily it can be developed. Modifiable, that is, if the client says for some modification, there should be a room for modifying. Okay. Traceable, traceability is verification, validation. What do you mean by actually traceable? It's nothing but once you have gone to one function or one point in the program, you should know from where you came and where you're going next. Okay, it's like you're tracking the control, where does it go and how you can actually work. Then forward traceability, that is you go forward in the code. Backward traceability is you go backward in the code. So requirements validation has focus, that is it ensures all requirements stated in SRS and checks for the quality of SRS, and the result of this is it produces a validated SRS at the end. So in this SRS, the next phase or the next next point is problem analysis. So what is the aim here? To understand needs, requirements and constraints on the software. So this analysis involves interviewing the client and users, reading manuals, studying current systems, helping client or users understand new possibilities, like becoming a consultant to help customers understand the need. And you must understand the working of the organization, clients and users. There are few code of conduct even in the companies, so that has to be followed. So what are important in this? Interpersonal issues are important, that is the language one person uses, especially the client, should be understood by the company team, right? What they actually mean by that. Then one more thing is the communication skill, what one says should be understood by the other, right? And the basic principle is a problem partition. You see, there will be client will be coming with a whole lot of problems. Okay, his idea, he will have so many things in his head and he want a software for that. So you need to partition that problem and ask them one by one what they need actually, like object, function and events in the system. Okay, so partition with respect to these things has to be done. Then system defined for multiple point of view, that is projection. You are trying to have the multiple point of view for the problem that the client has told. One more method is the informal approach. Informal in the sense there is no actual formal method for this, that is no defined methodology, and widely used because the software developed are usually a small scale one. People go with this informal approach. So here analyst acts as a listener, he absorbs the information and he interacts with the clients and end users, and he comes up with the idea and asks the clients to come up with a new idea, and they study the existing documents, questionnaires and all that. Okay, then problem in the analyst minds are directly translated to SRS. So and the analyst helps in translating it into SRS. So to do this, important, we have seen the modeling, right? Second phase was to do the modeling. So one easiest one or one that widely used is the data flow modeling. Okay, so it's widely used. It focuses on the functions performed in the system. Okay, what the function system uses, and views the system as a network of data transforms through which the data flows, and uses data flow diagrams, that is DFD, we call that as a DFD, and functional decomposition in modeling. So you are not actually showing the whole project, but you are showing the branched items in this project. And SSAD methodology uses DFD to organize information and guide. That is for you're using a methodology, it's called SSAD, and it is used to organize information and guide analysis. So it shows flow of data processed within a system based on inputs and outputs, used as a first step toward redesigning a system, provide a graphical representation of a system. The main important thing is the graphical representation, because you understand how the project is working with the help of the graph kind of thing. Graph is not like what you study in math, students. It's just like what we show it as in a flow chart. Okay, same thing, and creating an easy to understand picture of what the system does. We'll see with the example in the coming slides. Focus on what transformation happen, how they are done is not important, but the thing is usually major inputs outputs are shown and minor are ignored in this modeling. No loops, conditional thinking and all is not there, and it's not a flow chart. I gave you as an example as a flowchart, but it is not exactly the flowchart. That is why it's called as a DFT. And there is no algorithmic decision or thinking, and it consists only of sync and source and external files. See, this is the indications that are used. That is a rectangle for data source and link, circle for process, it's also called a circle or bubble, and it shows the data transforms, okay, how the data flows and all that. And data store, arrow mark is for the data flow. Say this is the DFT. So here you can see there is a worker. He is an entity. Okay, what he does, he works, right? He has an employee file in the system, that is in the employee record. Then he works weekly. He may work overtime, and there would be taxes. That this is from the database that is going to be deducted, and he will be given the paycheck. So worker, what does he do? He has a weekly timesheet, regular hours there are overtime hours, and he has an employee ID in the employee file. And if he works overtime, this has to be paid, and if for the regular, he has to pay this pay rate. Okay, so where does he get this file employee? From the employee record. Okay, then deduct tax also, it comes from the employee, it goes to the employee record, like how much tax has been deducted, and after the total has been done, total pay, from that tax is being deducted, and that goes to the net pay, that what exactly it is earned by the worker. So one copy goes to the company, and company records, they issue the deduct tax and issue the paycheck. That record also goes to the company record, and the check is issued to the worker. So this is how to read a DFT. Okay, so convention is external file show as a labeled straight lines. Need for multiple data flows process is represented by a star, that we call it as AND, or relationship is represented by a plus. Okay, and all process and errors should be named. You cannot keep it empty. See, these are stars. Okay, see, this is the star you are having, and this is the arrow, the process where it is going, you can get to know. This is the entity, and this is the process, whatever the process that is being done. So how do you draw a DFT for a system? First, you identify inputs, output, sources, sink for the system. Work your way consistently from input to output. That is, you start from input, stop at the output, and a few high level transforms, if any, you should identify them. Okay, and if at all you get stuck while drawing this, come to the reverse direction and do it again. And once the high level transforms are defined, then reach the transform with more detailed transformations. Drawing a DFT for system again is you cannot show the control logic, where the control goes. Okay, this is just the data flow diagram. You are only saying where the data goes and not the control. So loops, decisions, start, stop, everything does not occur in this. And you label arrows and bubbles carefully and identify the inputs and outputs, and you need to make use of a plus and star, which is not used in any of the diagrams or the graph you are using. And try drawing alternate DFs. Like, there is not only one DFD available for a system. Okay, there can be many. So try to draw if others are possible, and try to modify the original one. And in case if you get stuck, what you do, you come back, and if control logic comes in, you forget and you just come up with the control logic, then you stop and restart. Then you need to compulsorily label the arrows and bubbles, and you should make use of this plus and star, that is and or, and try drawing alternate DFTs. So there are levels for this DFT. That is, you start with the one level, and later, as I told you in the previous slide, you just go on increasing the size of it and add more detailed things to it. Okay, so that is how you do. So first we start with the single one, or for that first one we call it as level 0 DFT, which is also called as the context diagram. Okay, not just DFT, it's also called as the context diagram, and it's designed to be an abstraction view, like a bird's eye view, we say, no, like from far what it looks like. Okay, so that is done. Then it is in an entire system, it can be shown with a single bubble and just indicating the input and the output. Say this is level 0. Okay, this is for railway reservation they have taken. So ticket info goes to the passenger. He reserves the ticket. He might cancel the ticket. And here also in railway station reservation, what they give the information about the reserve and the cancel information is going to the admin, and passenger info also goes to the admin, and whatever the train he has to add, the admin can add to the system. Next is 11 that is a little broken down phase of this level 0 DFD, and it is decomposed into multiple bubbles, and we highlight the main functions of the system. See, this is level 1. So what happens? See, reservation storage is there. Where it goes, there is a reservation process. Okay, passenger, he goes through the reservation process. Also, he inquires. Inquiry from where they do it, or where the process can be done, from the storage, down storage and up storage. Okay, that is once when the when all the seats are available, and when the seats gets filled up, then one more database can be used. And once the reservation process is done, so reservation storage is done. When if it is reserved, then it goes to reservation storage. Then ticket generation process, that is you need to print the ticket, right? So a PDF or printed form will be generated, and that report goes to the admin. So these things happen in level 1. There is level 2. Level 2 is again detailed, and it can be used to plan or record the specific necessary detail about the system's functioning.